Hello friends, I Professor Darshan Thakur welcomes you on my YouTube channel for this subject head digital communication. Friends, as far as our today's session is concerned, so we will try to learn the different digital formats those are being adopted by this digital communication phenomena for the purpose of transmission. Means the objective behind this today's session is to learn the different techniques by which we can transmit that digital information bearing signal from source to destination. So let us quickly start our today's session. So basically, as far as these digital formats are concerned, which are broadly classified into three different types, right? These three types are nothing but what? First of all, we used to have the unipolar sequence, polar sequence, and third one is nothing but what? The bipolar symbol sequence. Means these are the three different symbol sequences by which we can transmit the digital information bearing signal from source to destination. Then again furtherly, these three types can be categorized as a non-return to zero type of sequence or return to zero type of sequence, or we can call it as a NRZ type of sequence or the RZ type of sequence, right? So with the help of one very simple example, we will try to learn how this digital information bearing signal can be represented is in terms of the equivalent electrical signal with the help of the two different voltage levels here, right? So first of all, see, this is the desired symbol sequence which we are interested to transmit, which consists of finite binary bits, starts from 1 1, 2 times 0, 1 and 0. So as we know, totally there are 6 binary bits we used to have with us, right? So what we need to do in this session, we are supposed to learn how this digital information symbol sequence is represented in terms of the unipolar, polar and bipolar type of sequence in terms of not return to zero and return to zero type of symbol sequence, right? So let us quickly go through. This is how these binary bits are being represented, where we used to have the particular bit duration which is uniformly defined for each and every binary bit, right? So that bit duration is denoted by this abbreviation called it as a TB, right? So TB stands for the bit duration for each one and each zero which is mentioned within this symbol sequence, right? So the first type of digital formats which are being used by this digital communication phenomena is nothing but what? The unipolar NRZ type of sequence, right? Where, as I told you earlier, NRZ stands for not return to zero, right? So in order to represent this digital symbol sequence in terms of this unipolar not return to zero type of sequence, unipolar means we used to have only one polarity, means we are having only one voltage level for sake of our convenience, which is to be denoted by this plus A volt, right? So this plus A volt is assigned to binary 1, right? And whenever we are having the signal transition, when that signal changes from 1 to 0 or 0 to 1, irrespective of that, it has nothing to do with this thing. The only thing which we need to understand here, this binary 0, we don't have any specified voltage level for this binary 0. So as it is denoted by this 0 volt, and binary 1 is denoted with this plus A volt, right? So as we do have the 2 times 1 initially, then 2 times 0, then 1 and 0, right? So this is the bit duration for binary 1. So during this bit duration, plus A volt is being assigned. Again, the second bit we are having with us is binary 1. So the same voltage level is being assigned to that second binary bit 1. After that, we do have two binary bits in terms of 0, right? So this 0 volt is being assigned during this bit duration, right? So this is the bit duration for first 0 and the bit duration for second 0. If suppose it is 1 millisecond, right? So for this 1 millisecond of time period, the 0 volt is being assigned to represent binary 0. And for this 1 millisecond of time, plus A volt is being assigned by that encoder. in case of this unipolar NRZ type of sequence. Okay, so after going through this unipolar type of not return to zero symbol sequence, in which binary 1 is being represented with plus A volt and binary 0 is being represented with this 0. Now the second symbol sequence is nothing but what? The polar NRZ type of sequence. Now in this polar NRZ type of sequence, as compared to the previous one, the same symbol sequence is having with us, that is nothing but what? 1 1 0 0 1 0. But as compared to the first symbol sequence, in this polar NRZ type of symbol sequence, there will be the two distinct voltage levels we used to have with us, which are nothing but what? The plus A volt and the minus A volt. So out of this plus A volt and minus A volt, plus A volt is being assigned to binary 1 and minus A volt is being assigned to binary 0. So as you can see, the first two bits we are having with us is nothing but for 2 times we are having binary 1. So this plus A volt is being assigned to these two symbols, which consist of 2 ones. Then whenever we are going through the signal transition, when that signal changes from 1 to 0, right? So for 2 times 0 we used to have, so this minus A, this negative voltage is being used or assigned to represent these two symbols. Then again that symbol changes from 0 to 1. So at that time this plus A volt is being assigned to represent this binary 0, and again this minus A volt is being assigned to represent binary 0. Means there are two identical voltages, positive and negative, to represent binary 1 and 0. That is nothing but what? The polar NRZ type of sequence. Then the third one is nothing but what? The bipolar not return to 0 type of sequence. So this is how that symbol sequence is being encoded with the help of this bipolar not return to 0 type of sequence. So in this bipolar NRZ sequence, the unique identity belongs to this bipolar NRZ sequence is nothing but what? Now in the previous case, this positive and negative voltage is being assigned to different signal level for binary 1 and for binary 0. But the unique identity of this bipolar NRZ type of sequence is nothing but these two different voltages are being assigned to say the same signal level, right? Means the plus A volt and the minus A volt, these two voltages are being adopted for binary 1. We are not assigning any voltage to binary 0, right? So see, this is the third sequence, this is the third representation level in which we are having plus A volt and the minus A volt. So this alternatively, this plus A and minus A volt, these two different voltages are being used to represent binary 1. It is not adopted for binary 0. For binary 0, the 0 volt is being assigned, right? So in that alternating manner, how it is being assigned, let us quickly go through. For this first binary one, this plus A volt is being assigned, right? For second binary one, this minus A volt is being assigned, right? Then in that third alternating cycle, or in that third transition bit, when that sequence changes from 0 to 1, here plus A volt is being assigned. So in this alternate fashion, this plus A and minus A, this positive and negative voltages are being adopted for only binary 1 in alternating manner. It is not adopted for binary 0. So this is the unique identity belongs to this bipolar NRZ type of sequence, right? We had discussed the unipolar NRZ, polar NRZ, then after that bipolar NRZ, right? The unique identity belongs to unipolar NRZ is nothing but what? Only positive voltage is being assigned to binary 1. In case of this polar NRZ type of sequence, positive and negative voltages are being assigned, or these two voltages are being adopted to represent binary 1 as well as binary 0, right? But the third symbol sequence is concerned bipolar NRZ. In this bipolar NRZ type of sequence, this plus A and minus A volt, these positive and negative voltages are exclusively used to represent binary 1. It is not being adopted for binary 0 in alternate manner, right? So after that, the fourth one is nothing but what? Again, these three sequences we are having unipolar, polar and bipolar. But as I told you earlier, these three techniques can be categorized as a NRZ type and RZ type of sequences. Okay, so fourth one is nothing but what? The unipolar return to zero type of symbol sequence. Already we had discussed the unipolar not return to zero type of symbol sequence. So when we compare this unipolar RZ sequence with the first sequence which we had discussed, so we will come to know that there is quite similarity in between these two sequences, right? The similarity in the sense that unipolar means there will be only one voltage level, that is nothing but what? Plus A. Similarly, in that first sequence also we used to have only one voltage level, that is nothing but what? Plus A. But the main difference in between the unipolar NRZ type of sequence and the unipolar RZ type of sequence, RZ means return to zero. So during that signaling interval, that waveform will try to touch to that zeroth axis. That's why it is being called it as a return to zero. So by taking into account this fact, carefully you just try to see this plus A volt is being assigned to represent binary 1 during the first half bit duration of that binary 1, because this is nothing but what? This is nothing but the bit duration for binary 1, if suppose it is 1 millisecond, right? So out of that 1 millisecond, for first 0.5 millisecond, this plus A volt is being assigned, and for the remaining 0.5 millisecond, the 0 volt is being assigned, because as it is return to zero type of symbol sequence, right? As it is a unipolar return to Z type of symbol sequence, so this voltage is being assigned only for binary 1. Whenever we are going through this binary 0, so at that time what will happen? The 0 volt is being assigned, right? One more time, carefully just try to see how this second symbol, that is nothing but what? Binary 1 is being represented. Again, in order to represent this binary 1, this is the bit duration for binary 1, which is of 1 millisecond, right? So out of this 1 millisecond, for first 0.5 millisecond, this plus A volt is being assigned, right? Once this plus A volt is being assigned for first half of this 1 millisecond, for remaining half 0 volt is being assigned, right? So this is how this unipolar RZ type of symbol sequence is used to encode the digital information bearing signal by assigning the resultant potential for only the first half bit duration. For the remaining half bit duration, 0 volt is being assigned, because as this is the unipolar RZ type of symbol sequence. Then after that, the fifth one is nothing but what? The polar return to zero type of symbol sequence. When we compare this polar RZ symbol sequence with polar NRZ type of symbol sequence, so then we will come to know that there is one quite similar, or there will be one similarity in between these two symbol sequence. That similarity is nothing but what? As it is a polar type of symbol sequence, whether it is RZ or NRZ, always we used to have the two different voltage level, plus A volt and minus A volt, which is used to represent binary 1 as well as binary 0. But this is the RZ type of symbol sequence. Then what will happen in this polar RZ type of symbol sequence? This plus A volt is being assigned to binary 1 for first 0.5 millisecond, right? For remaining 0.5 millisecond, 0 volt is being assigned. Similarly, the next bit is nothing but what? Again binary 1. So for this 0.5 millisecond, plus A volt is being assigned. Then after that, 0 volt is being assigned. Whenever we are going through this binary 0 symbol during this bit duration of 1 millisecond, so at that time, for that first half, this minus A volt is being assigned, because this is this symbol, this is nothing but what? Binary 0, as we are having the polar RZ type of symbol sequence. So for remaining half bit duration, 0 volt is being assigned. Similarly, the next bit is nothing but what here? Again it is 0, right? So this 0 is being represented by assigning this minus A volt for this half bit duration, right? For remaining half bit duration, 0 volt is being assigned, right? So polar in the sense, this plus A volt as well as minus A volt is being assigned to represent binary 1. and binary 0. But the difference is what? This plus A and minus A volts, these two identical voltages are being assigned only for first half bit duration, for binary 1 and for binary 0. For binary 1 it is plus A volt, for binary 0 it is minus A volt. For remaining half it is 0. Then after that, the symbol sequence number 6 is nothing but what? The bipolar RZ type of symbol sequence, right? So bipolar RZ type of symbol sequence means what? In that symbol sequence, again we used to have the two different voltage level, plus A volt and minus A volt. But when we compare this symbol sequence with this previous one, so we will come to know these two different voltages are being adopted for only binary 1. This negative voltage is being not adopted for binary 0. For binary 0, this 0 volt is being assigned. This is 0 volt and this is also 0 volt, because which bit we are having with us here? 0, this is 0 and the last bit is also 0. So the remaining bits are nothing but what? This is 1 and this is also 1. So how this 1 is being represented? The first one is being represented with this plus A volt, and the second one is being represented with this minus A volt. Means in that alternate manner, this plus and minus A are being adopted to represent binary 1. Right. Then for third one, which voltage level is being adopted? After this minus A, this plus A volt is being assigned. After this one, if suppose we are having one more one, so for that one, this plus A volt will be used. Right. So this is how this bipolar RZ type of symbol sequence is being used. Then the last one is nothing but what? The polar Manchester type of symbol sequence we are having with us, right? So in this unique symbol sequence, let us quickly go through how this information bearing signals are being represented, in which we are having finite number of ones and finite number of zeros. So first two symbols we are having with us is nothing but what? Binary 1. The second two symbols are binary 0, then 1 and then 0. So how this 1 is being represented in case of this Manchester polar type of symbol sequence? Again, we used to have these two voltage levels, plus A and minus A. So last one is nothing but what? The polar Manchester type of digital format. So in this digital format, again we need to understand how these two voltages are being adopted by this digital communication technique to represent binary 1 and binary 0, right? So the first bit we are having with us is nothing but what? Binary 1. So this binary 1 is being represented with the help of this plus A volt as well as minus A volt, because during that first 0.5 millisecond of bit duration, plus A volt is being used, and during the remaining or during the lower half of this 0.5 millisecond, this minus A volt is being used. Means high to low for binary 1 in case of this Manchester polar type of encoding. Again, the next bit we are having with us is nothing but what? Binary 1. So for first 0.5 millisecond, this plus A volt. For remaining 0.5 millisecond, this minus A volt is being used. Then when that signal changes from 1 to 0, so at that time, for this 0, during the first 0.5 millisecond interval is represented with this minus A volt, and the remaining 0.5 millisecond interval is being represented with this plus A volt. Means low to high for binary 0. Again, the next bit we are having with us is nothing but what? Binary 0. So for that first 0.5 millisecond, minus A volt, and for remaining 0.5 millisecond, which is to be represented with this plus A volt. And the next bit is we are having with us is nothing but what? Again it is 1. So opposite to that, for first 0.5 millisecond plus A volt, and for remaining 0.5 millisecond it is represented with this minus A volt. Means whenever we are having this binary 1 which is to be represented with this plus A volt for first 0.5 millisecond and minus A volt for lower 0.5 millisecond. Opposite to that, in case of binary 0, this minus A volt is being used for first 0.5 millisecond of interval, and plus A volt is being used to represent the remaining minus 0.5 millisecond of bit duration, right? So in this way, these different digital formats are being used by this digital technique phenomena to transmit this digital information bearing signal from source to destination in terms of these two voltages. For sake of our convenience, it is to be considered as a plus A and minus A volt, right? So I just hope that you had understand all these digital or the data formats which are used in case of this digital communication phenomena. Thank you.